using AppDynamics. Our guest speaker today's webcast will be brought to you by Thair from the DevOpsGuys. If you have any questions, just enter them in the chat and we'll answer them at the end. For now, I'll pass you on to Stephen.
Thanks, B. Good afternoon, everybody. Welcome to the webinar, first of all. We're going to talk about improving performance and driving value using AppDynamics. Obviously, as an organization named DevOpsGuys, I'm probably going to be looking at this through a DevOps lens, how we can improve development, how we can improve operations, and how we can improve collaboration between dev and operations, and the role that APM tools, in particular AppDynamics, can play in that. I'm going to run you through some background concepts, and then we'll finish up with a live demo so you can actually see the product in real life and make sure I'm not just making everything up. So without further ado, it says, happy me. This is me, DevOpsGuys. We're an application management provider. It's all about providing on-demand operations as a service to people who don't want to run their own website operations, and helping people build continuous delivery pipelines for those people who want to move into CI, CD, and DevOps model to be able to get their applications out into production faster and accelerate the growth of their business. That's enough about me. What are we going to talk about? Well, first of all, we're going to talk about what is APM. Why do organizations feel they need APM? The benefits that APM can bring you. And then we're going to do a AppDynamics live demo, and if we've got the time at the end, we'll do a quick Q&A. So APM defined straight from Wikipedia, the source of all truth. It's actually not a bad definition as by Wikipedia standards. It's the monitoring and managing of the performance and availability of software applications. Strives to detect and diagnose. APM is the translation of IT metrics into business meanings, i.e. value. And I think that's a key differentiator between sort of APM tools and your traditional infrastructure level server tools that were focusing on CPU and disk and memory utilization and things like that. And those early infrastructure-centric solutions had no concept of business value whatsoever. So it's a really important distinction there. Gartner, another source of truth, broadly equivalent to Wikipedia, have 5 dimensions of APM. This was sort of their rejig of what APM means in 2013. So end user experience monitoring, so giving a measurement, generally in the browser, or by using synthetic monitoring of exactly what the end user experience is. Application runtime architecture discovery and modeling. So when you install the application, it'll go out there and model your application and profile it for you. So go out there and discover it and then model it for you. User-defined transaction profiling. So it's bringing the transaction metrics at the deep dive and aggregating them together or bringing them together into a business transaction metric. So I'm not just looking at something through digital, I'm looking at a transaction, maybe that's checkout, maybe that's search, maybe that's, view product detail. Those types of transactions that make real sense to you, login, et cetera, that make sense in an e-commerce context, make sense in an application context, not just arbitrary developer level metrics. But we've also got to do deep dive monitoring, application component level analysis, and we've got to bring this all together into reporting and application data analytics. So they're the 5 factors that to get onto the Gartner Magic Quadrant for application performance monitoring that you've got to meet. So segue nicely into the Gartner APM. If we look at the Magic Quadrant back in 2011, you'll see, in the top right-hand corner, the leaders on completeness and vision and ability to execute is all your traditional vendors, IBM, CompuWare, Computer Associates, HP, with a couple of challenges out there, OpNet and Optia, and sort of everybody else down in the bottom. What we see if we move forward into 2002, we see the new entrants like AppDynamics coming in, got new Relic, and we see a number of the traditional vendors moving, down and to the left, which is not the direction you want to go. You want to be up and to the right. If we can go forward into 2013, we sort of see that the only people who are really making it into the upper corner are the new vendors. All the traditional vendors have moved out. You have AppDynamics, New Relic, Riverbed. I'll explain in a moment. Even though this is Riverbed, it was actually a third-party product, and CompuWare with their acquisition of Dynatrace. So Avocode, originally focused in the .NET marketplace, acquired by Microsoft about 3 years ago, now forms part of Microsoft Application Insight Suite. OpNet, which is the one which was acquired by Riverbed, now forms part of their Riverbed APM suite. Dynatrace, acquired by CompuWare, now called, we're still branded as Dynatrace, which is called CompuWare APM. New Relic, still a standalone, looking to IPO, well, was looking to IPO in 2014. I don't know whether that's still on the plan. And AppDynamics as well, still standalone startup, VC funded. Again, also getting very close to an IPO. And both of those are looking at sort of hundreds of millions, if not billions of dollars, US dollar valuations. So, very hot vendors in that space. Some have already been acquired because the traditional vendors just can't keep up with the rate of innovation. They can't keep up with the new challenges in the space.
Steve,
So legacy vendors.
For a second.
Yeah.
I think there might be a problem with your slides moving. I'm still on your title screen at the moment.
Oh, heck. Okay.
That's better.
That's
yeah, there we go. Thank you.
Sorry about that. I will quickly go back a couple of slides then. So 5 dimensions of APM, which I've talked you through. Do you need to recap on those, or does that make sense? No? Yep, okay, cool. So this was the Gartner Magic Quadrant that I was talking about. And as I said, we can walk through this lovely animation. We can see the traditional vendors moving down into the bottom corner. Avocode, acquired by IBM, OpNet acquired by Riverbed, Dynatrace acquired by CompuWare, New Relic and AppDynamics still as independent vendors in the space, but as a general rule, the traditional vendors are moving in the bottom direction, and only those vendors that have actually acquired a startup in the last year or so are still making it into the top corner of the AppDynamics Gartner Magic Quadrant. So according to the APM Digest, there's 15 reasons why you need APM in 2014. You can see all of those there. I kind of grouped them together into 3 major areas. I think this is stuff that's all about, agility. It's all about getting products to market faster, doing more with less, and and about the increasing sort of people wanting to do more and more faster. There's another sort of group which is all about the complexity of the environments that we're moving into, and then there's another whole section around mobile mobility, bring your own device, around the expansion of the types of clients that we're expected to support, and that brings its own complexity. So DevOps agility, application complexity, and multi-client. And one of the outcomes of the multi-client approach is people moving to an API-first model, moving to a model where you start with an API that can be then used to build multiple clients, whether that's a responsive mobile client, a traditional browser web client, native client for iOS and Android, or an integration with third-party services via your API. I think there's also a 4th reason, which is that you don't want to be like Ticketmaster and appear on the front page of the Daily Mail, telling you about how your website was struggling and crashed, and basically having a PR disaster because you weren't able to stay on top of what of the traffic that was coming to your website and the performance and scalability of your website. So yeah, the fourth reason is you don't want to be flagged off in the Daily Mail. So benefits of APM, 4 quick benefits: seeing the big picture, drill down to the details, faster feedback cycles, so agile enablement, and stop the blame game. And then we'll quickly talk through each one of these with some real-life examples from customers that we've worked with and how we've addressed some of these problems in using AppDynamics. So number 1, seeing the big picture, systems thinking. So for those of you, very quick systems thinking 101, what is systems thinking? Systems thinking is basically a fancy way of saying looking at the big picture. Somebody described it as practical holism. It's about looking beyond the silo. That's another great message of DevOps, and looking at the application as a whole and how it interrelates. And you're looking to extract patterns rather than just looking at point-in-time information. So it's about time series analysis and trying to see the signal for the noise. You know, that aligned with that is these concepts of moving from a command and control model to a systems thinking model, and it's about looking at demand, value, and flow, particularly how things are flowing through the system with this outside-in perspective. So let's take a quick example of that. We were working with a customer. They come us to a new website, and they were getting really high data start times on page load and poor load testing results, looking at their capacity. We had a conversation with the client. They then came back 2 weeks delay while their hosting provider scaled out some more hardware. They said, oh, look, you know, we think we know where the problem is. We don't want to engage with you now. We're going to go away and throw some more hardware at it and see if that solves the problem. Unsurprisingly, after that 2 weeks of throwing hardware at the problem still wasn't fixed. So they engaged us to come in and install AppDynamics in their environment and try and troubleshoot the problem. So that's kind of what the page load looked like. You can see that blue line in the top corner. This is a standard page load waterfall diagram from a third-party synthetic monitoring tool. So, but yeah, it doesn't look great. So, excuse me for a moment. The real thing is we're trying to get to what's the root cause is it's 1 second data start time, which is just killing the user experience for the customer. So, answer that question. We installed AppDynamics, and this is what their application looked like in the application flow map view of AppDynamics. So essentially, in the middle, you've got the green box in the middle, which is their .NET application web tier, which is going out and talking to a number of endpoints. The traditional database silo symbol, clouds for web service endpoints. And it was very, very apparent very, very quickly once we looked at it in AppDynamics that there was this massive 4,306 milliseconds, so 4.3 seconds in this call to their ERP platform, which in their case was the Navision platform. So, you know, it was immediately, obviously, literally within an hour or so of installing the application, but this was their biggest bottleneck. There was also a number of quite significant bottlenecks. You know, 92 milliseconds to do a web service call, 116 milliseconds to do another web service call out to their recommendation engine. So their pages had the option there. People who bought this also bought XYZ type recommendation. That was a service that was provided by a third party. Given that your goal for your overall data start time for a web page, in order to get a sub 3 second page load time, you're trying to get a data start time of around 100 milliseconds. If you're doing 100 milliseconds of the data start is just to go out there and get the recommendations, you're never going to achieve that kind of goal. So, you know, they took a number of immediate actions. They contacted the vendor for the recommendation engines, and they said, "Oh, sorry, you're still on our trial platform. We haven't moved you over onto the dedicated thing platform." So they made that change, and that problem went away. They went and had a look at their Navision platform. That caused them serious problems. They had quite a bit of code refactoring to do. But eventually the outcome was this insight. They knew exactly where they needed to focus their efforts. So getting that big picture really delivered value for them. So the next thing is to be able to go from that systems thinking, holistic, big picture to actually drill right down. Traditionally, my background is in operations. So, with the limitations of the tools that we traditionally had in the operations, the developers would deploy an application out, and we would have a conversation like, well, it seems to be using a lot of memory. It seems to be using a lot of I/O. It seems to be using a lot of CPU. And the developers would generally look at it as a blank slate because that just really wasn't sort of information that they could do anything with. It was like, yeah, great, but tell me where, how do we go back down? And then you were sort of trying to pull developer profiling tools and attach them to a production system, or trying to find better ways of generating load to recreate the error. And it was just a horrible nightmare. The benefit of tools like AppDynamics, this is a call Drilldown, which if you're a .NET developer on the call, you would recognize this is stack trace. And you're looking at the call graph from the entry point from the ASP.NET framework as a HTTP request, drilling down through the various handlers and until you sort of, as you see in this method here, there is a method which is taking 671 milliseconds. And the benefit of this is that I'm able to go down and have a look at what this call is actually doing. And in this particular example, we were able to look at the SQL calls that were related with this activity, and we could see that the largest amount of time that was going on was this total 281 milliseconds, 41%, 42% of the time was actually doing a connection open. There were 6 connection opens being called, with an average time of about 46 milliseconds. Hopefully you can actually see, but any of you that are used to connection strings will immediately see a problem, and that's that connection tooling has been disabled on this connection string. So therefore, every time you want to make a database connection, you incur the overhead of creating and establishing the connection with the database, rather than reusing a pool of already established connections, which would basically effectively make this connection open time 0 after you've established the first connection and created a pool of reusable connections. So again, really, really useful feedback that myself as an operations guy, I can go to you and say, right, the problem that as we see it, the vast majority of time is being spent in this method. The vast majority of time is being spent in this database call, or in a case like this where it's blindingly obvious where the problem is. Can you please change the connection string to pooling equals true, and push that change back out through the through your continuous delivery pipeline, redeployed it back into production, bang, job done, problem solved. So it's really facilitating a much more meaningful diagnostic, rather than just trying to hunt around log files and hunt around server statistics. So faster feedback cycles. So another real world example, in a previous job I used to do a lot of load testing. I worked for a performance testing company, and we were doing a load test for a customer, working very, very closely with the developers. So we started at 9 AM, we worked 12 hours through, we finished up at 9 PM, and by the end of the day we were 56 times faster because we'd gone through 4 release cycles in that day, and we were able to really generate some value. Now obviously we had 4 just the 6 cycles. Obviously we had a number of real advantages. We had chat connection with the developers all throughout this whole cycle. The developers were used to doing agile. They were ready, willing, and aligned up to do some rapid fixes during this day. They had the mechanisms to push those fixes out. So every time we gave them an application insight that we were generating from AppDynamics, they were able to go and say, yeah, actually, we think we know that we can refactor this code. We're going to do it. So it was, refactor, repeat, refactor, repeat. And the end results were, were fantastic. 56 times faster on average, 3.5 times throughput, or another way in terms of requests a second, 3.5 times the capacity available to you on a given piece of hardware. And there's a really nice feature in AppDynamics actually, which is seen at the bottom here, where you can define two custom time ranges and simply do a before and after comparison, and it will show you the load, throughput, errors, etc., between those comparisons. Really fantastic feature to use when you're doing a release, for example. You can define a time range. This is the hour before the release. This is the hour after the release. You can mark your releases as a custom event in AppDynamics. So you can put a mark on a timeline that says that we did a release here. There's an API to drive those in so that you can actually have your Jenkins or Octopus deploy, or however you're actually pushing out your mechanisms you're using to push out changes, can actually automatically send an information to say at this point in time I made this change for this reason. That'll appear in the next timeline, and then you can use that to do before and after comparisons, which is a fantastic feature, and we use it a lot. So very easy to see in this graph. This is what the performance line looked like before. Spiky jagged, and really once the load starts to increase, starting to trend upwards after about the 35-minute mark. And this is what the performance line looked like after, down in the tens of milliseconds range, which is what we're looking for, and absolutely flat across the range that we tested on. So fantastic result. Very, very happy customers. I think one of the other softer benefits of APM tools is promoting collaboration. It's a bit of an unusual one to talk about because people generally want to look at all of the hard metrics, but I think it's worth talking about, and I think it shouldn't be underestimated. When you tend to have a performance problem, you tend to be in this situation where everybody's pointing fingers at each other, and the management just doesn't really care, and you're just coming down from the top and saying, you fix it. Everybody, I think, has ever worked in IT at some point has been in the war room. You get a nice big conference room, you get everybody in there, and the conversation generally, unless you've got some really strong leadership, can very rapidly deteriorate into operations saying, well, the hardware is fine, and QA saying, well, we didn't see anything in testing, and Dev saying our code fine, and if there's a third-party vendor in there, we'll point the finger at them as well. And eventually, management just doesn't care. Management just says, look, fix it, solve the problem. So how do you turn around this paradigm everybody playing the blame game? Well, the easiest way to turn that paradigm around is to try and create the Fixit Game. And the Fixit Game is about, well, if I have an unequivocal source of truth of what's happening in my environment, that gives me the ability to start with a big picture and then drill all the way down into the details. Everybody can be pointing at what the data is telling you. I'm moving away from opinions and I'm moving into the realms of facts. So we can divide the work up based upon this analysis and say, well, we're going to look at this area and this area and this area. And then we can start to experiment. If we think that X is going to fix problem Y, then let's do X, and let's go and use that comparison feature I showed you in the earlier slide to actually compare what's going on. And we can come back, as we did with the earlier load testing, rinse and repeat, and go around again. And, I've seen this dynamic work, and the problem gets solved a hell of a lot faster, and B, the experience of the people who are involved in this starts to become a much more collaborative experience. Everybody is focusing on the data and not focusing on who's at fault, focusing on the problem, not focusing on the blame. As the good old Mythbusters guys would say, well, there's your problem. You've got to have that ability to isolate the problem and get people talking about it. So that's the quick whiz-through overview of the big picture of some of the reasons why APM tools can deliver value. So we're going to segue into a short demo of AppDynamics. Before we do that, I'll give you a very quick overview of the AppDynamics architecture. for those people who aren't familiar. Like most of these types of applications, you have an agent. The agent goes and is installed onto the server or into your JVM or into your your .NET application pool. It's a very, very simple installation in the .NET world. It's really, running one setup and exe and a quick wizard that asks you 4 questions: how to connect to the controller and which app tools do you want instrumented. In the Java world, it's putting some entries into a configuration file and then adding a command line parameter to bring you fire up a jar. And then there's a machine agent. In the .NET space, machine agent is actually integrated into the same setup that exe. Again, it's just a single daemon in a Linux environment. So these agents, the application server agent in particular, will instrument your application using a technique called bytecode instrumentation. It will go out there, it will automatically discover all of the entry and exit points external to the class or the method that you're looking at. It'll look at the interfaces across the methods, and it'll report metrics back, effectively putting timers around those entry and exit calls from external endpoint calls. And the machine agent again is going out and pulling back metrics, and it's configurable in .NET world. Well, in both environments, it comes pre-configured with a whole bunch of metrics that it will collect. In the .NET or Windows world, for example, you can also tell it to collect arbitrary perfmon counters. And again, in the in a Linux Unix world, you can write additional scripts, small scripts or something to get it to report additional metrics. So you've got a lot of flexibility in the data that you report. That gets fired into a controller. In one of the probably the major distinctions of AppDynamics is that it gives you both a SaaS option and an on-premise option. Not all the other providers do give you that option. You've got this user interface. You can go to a cloud portal, your on-Dynamics controller. To be honest, I don't do a lot of work with on-premise controllers, simply because most people want to take the advantage of a SaaS solution. There are reasons that you might want an on-premise controller for security reasons, or depending upon the actual total data volume that you might be collecting. And there also might be some reasons, like if you want to extract information from the API to feed other sources, it may be easier to do that from an on-premise controller compared to a SaaS controller, depending upon your network and application configuration. AppDynamics also has end-user monitoring, effectively a piece of JavaScript which is inserted into every web page to access the navigation timing API, which is a standard across all the browsers now, including Safari as of about last month. And there is also a mobile monitoring agent, which is a library that you can include into your iOS or Android application to gather metrics about the end user experience, and that all sort of feeds into the pipeline. There are additional third-party add-ons for various applications. There is the Node.js collector now, which is relatively new. There's AppDynamics for databases, which will pull together applications, statistics and metrics, and everything you want to know about your SQL code. That's not yet fully integrated into the AppDynamics portal. It's still a standalone screen. I think that integration is very, very close. But so that's just the overall architecture: agent, controller, portal. Oops. Let's go back. And let's go and jump over into AppDynamics. So this is the AppDynamics. This is the AppDynamics portal, what's called the application flow map. And for my money as an operations person, this one screen is the screen that's pretty much, it's worth the money for it alone. Effectively, what you're seeing here is the web tier for it's a movie ticket online application. Here is the web tier I'll just trace the transaction flow for you. You can hover over any tier at any time and get some information about the health of the nodes, the at response line versus the baseline. And coming in here to a core services tier. This services tier is going out to IMDb to pull back some information about the movies and the actors. It's doing some logging into a SQL database. It's doing some calls to a movie database about what movies that are on at their cinemas. It's calling a payments web service gateway, and that payment gateway is doing an MQ series call over into the movie processing backend, which is calling Visa payment service, and there's confirmation again, putting the response back to say, yes, you have booked this seat for this cinema at this time, popping it onto a confirmation queue, back into the confirmation service, back into the database, and then flowing back out to the customer. So it's a pretty straightforward e-commerce application. The key thing about this is that I don't have to do anything to create this view. All I needed to have done is to install the AppDynamics agent onto the boxes that are actually running the application code, and AppDynamics discovers the rest. It discovers the interconnections between them. It discovers the endpoints. It discovers the databases. So as opposed to, you know, lots of sort of very, what are called first generation or second generation APM solutions, where a lot of this stuff that you would have to be manually dragging, you know, applications in and on, very, very simple, very, very straightforward. And it's fantastic for operations people who are often focusing down at an infrastructure level to actually take a step up and say, okay, let's look at the big picture. Let's visualize the application flow. There's obviously other useful information on the dashboard. I can come in there and I can exactly see, you know, what the load is in my application at any one time. I'm averaging 204 requests, the calls a minute, and I can see my application response time averages. I can see where my error rate is going. I can see here very quickly that the average has jumped up massively. And then there's this idea of transaction scorecards, overall business transaction rule, and health rules. Again, health rules is effectively an alerting mechanism that says, you know, based upon well, some thresholds that some are out of the boxes and some that I can configure. Tell me what's going on with my application. So if we want to go down from the application flow, the next level down in the hierarchy, we start to look at transactions, and this was what I alluded to at the start of the presentation, where, you know, we're looking at things that have real meaning to the business users. You know, how many people logged into my application? How many people, you know, completed a checkout? How many transactions were happening at search? How many transactions were happening at reviews? I mean, depending upon your application architecture, this information is absolutely critical to how you structure your application. I might be moving towards a microservices architecture and say, well, actually, I'm going to put the movie reviews, for example, you know, out onto a different tier, or in particular this case, the API for calls to the search, and I can scale that tier independently. Cool, sorry about that. And it's very, very quick for me to see in what's getting the maximum amount of load, and more importantly, what's the slowest. What's slow transactions by call, absolute time, average view by response time. So the movie review call is the slowest. We can immediately see that. So let's drill down into the movie reviews. So the next tier down in the hierarchy, so I've gone from the application flow, I've gone to a business transaction. Now I'm drilling down into an individual business transaction, and now I'm starting to look at snapshots. So AppDynamics has the concept of snapshot. Snapshot is basically a point-in-time collection of data about a single execution flow of that transaction. How many snapshots that it collects is completely configurable. AppDynamics has a very, very nice feature that it will periodically detect a snapshot. Collect the snapshot, but it will also do some interesting things that if it starts to detect that an application is running slowly, it might, or a transaction is running slowly, it might increase the rate of snapshot collection to try and drill down and find some more information around that. And all of those thresholds are configurable both in terms of absolute sensors, but also in terms of sort of standard deviations and statistical analysis. So if I drill down into a particular snapshot, I get the snapshot flow map, so quite familiar to what we saw before. And we see here, we have our movie search site, which will show me what's happening at the web tier. And the answer is not much happening at the web tier other than making a call to this WCF service layer. Go over into the service tier, and I can see some interesting stuff here. So straight away, well, okay, I'll go back. Summary view, we can just find the specific information, exactly when and where and what and why and how this thing was that this was created. So that gives us some details. Depending upon how your authentication works, you know, it might be including stuff like session ID and who was actually logged in. One really nice feature that you can do with AppDynamics, on pretty much any screen you have the concept of a link, so you can copy a link to a clipboard. If I want to send this information to somebody else, I can simply just paste it in, and they'll be immediately taken to that location and that snapshot that I've sent to them. Wait for the GUI to load. I'll come back to that. Oh, it's coming up now anyway. Which is fantastic. Again, it's an operations person. I don't have to sort of try and say to somebody, I'll try and find this snapshot with this date and time or whatever. I can send somebody directly to it. So it's really, really good. You put it in a Jira ticket, you fire it back to the developer and say, I've noticed this really weird thing going on. Here's a snapshot that clearly demonstrates the information. Go and look at that snapshot for me, please. You can also export it into a PDF document as well. So if I'm looking at this, I come into the call graph, I'm looking at this trace stack of what's going on. One of the first things I can quickly do is get to the hotspot view, which is effectively their language for saying, tell me the slowest thing that's going on in this call. In this particular case, it's a call to HTTP web request get response. So it's a call to an external web service. I can quickly say, okay, so show me that hotspot in the call graph. I'll come over here. I'm in the call graph. Now I can see it in context. Okay, so it's coming all the way down. I'm getting, so call services review. So I'm getting the review. I'm checking the cache. I'm obviously not in the cache. I'm going to go down and I'm going to actually get this review. I'm going to have a look at this this call. So this is my API call to IMDb. So straight away I'm looking at it here saying, well, wow, 2.34 seconds in order to get a review from the IMDb website. So now I know why they want to have a cache layer in here, because that's obviously unacceptable. You're only going to have so many movies that you're showing in your movie theater at one time. You shouldn't be wasting 2.34 seconds every time you go and want to do a call. So straight away, maybe I'd be going back to the developers and say, look, I'm not seeing a lot of cache activity here. These calls seem to be dropping straight through into calling IMDb. That's really, really slow. Can we talk to IMDb to speed that up? That's one thing. More importantly, can we understand why the cache layer is not caching this this application effectively? I can go through also and it's actually .NET application, so where they're using LINQ for SQL, which is a relational object database mapper. So I'm interested in what this actual SQL call is. So there's two ADI.NET calls here. I can see there is the there you go, pooling equals false. Although in this particular case it was only really making one call, so it's relatively fast. But I would go and fix that, because who wants pooling equals false? and we can actually come in and see what's happening. In this particular case, you can see select movie, select review URL from movies where movie equals blah blah blah. So it's going out and finding the endpoint URL it needs to call to get review. So fantastic! You can go in there and immediately see what, how long this database call is. From 733 milliseconds to execute a query like that is terrible. So you would really want to go in there and have a look at the performance. You always want to go and have a look at the performance of link for SQL or any object data mapping thing, because generally the performance is absolutely terrible, but you can immediately, again, get some useful information. You can also see that very, very quickly from this view if you just want to jump straight to looking at the SQL. Just so you're aware, we mentioned before about the machine agent. .NET machine agent is actually built into the installer and installed in by the same installer. But you can look at any point in time the metrics of what's going on the box. There's an entire metrics browser that I'll show you. But again, in order to try and contextualize it to aid with your troubleshooting, AppDynamics will very, very quickly put some of those metrics that you're most likely to want to care about right next to you in the context of the troubleshooting you're doing. So again, they've thought about exactly what you might want to go and have a look at. Okay, we'll put that one to one side for the time being. Okay. So again, observed 81. So hard drive resources, disks, kilobytes written per second. The observed value is 81. The baseline value is 37. We're looking at the standard deviation, not all that much actually. So, why did we have a spike in disk resources at that time? Maybe that's something from an infrastructure perspective that I might want to go and have a look at. I think just one thing to probably measure there, to mention there, is this concept of the baseline value. AppDynamics will calculate baselines, rolling averages over the last 30 days or last 7 days of the time period that you want to configure. And it's very, very useful because you get that out of the box, and it gives you this sort of trend line that you can drill in at, having a look at exactly what's happening, compared to the baseline. And that's a feature that kind of runs throughout all of the AppDynamics stuff. This concept of the baseline and statistical modeling of your application. So when I'm looking at a particular value and I'm going, well, is that good or that's bad? And that's bad. I don't really know. Well, what was the baseline value over that time period? As you can see, you can stack these up out of the way at any one time. Okay, cool. There is actually EUM enabled on this application. So end user experience monitoring, also called real user monitoring, or RUM, is the idea of actually looking at how long it takes something to load in the actual user's web page. So for an example, we're here, in order to on average to load the movie review page, it's taking 4.277 seconds, which is above the ballpark figure of 3 seconds that we try to aim at. We generally sort of say that people are going to start to drop off. I'm going to have conversion problems if I've got page load times over about 3 seconds. So again, this is really useful information. I can start to see the geographic spread of the information that's available of my customers. That might feed into my DNS strategy, my caching strategy. How am I going to bring this information closer to the endpoint to reduce latency? And obviously, you can also see that there's in this particular case there aren't any iOS and Android requests being shown, but you can see that there is the option for that to actually pull metrics in from iOS and Android. Just checking on the time. Okay, very conscious of time. We're starting to run out of time. I just want to show you one more quick thing, which is one of my other killer features in AppDynamics. There are so many other features in AppDynamics. You can see one down here called Cloud Autoscaling, for example. As you would expect, there's lots of alerting and all those kind of stuff that you won't want to do in AppDynamics when you detect particular things. But one of the things that I really quite like in AppDynamics is cloud autoscaling. So if you're in an autoscalable cloud environment, you can get AppDynamics to say, you know, when average business transaction time, you know, grows by one standard deviation, then add in another web server or add in another app server and try and bring that time back down. So rather than trying to use like CPU metrics, you know, when a web server is 65% CPU bound, then add a new box into, well, let's look at real metrics that make real business value. So we've got a business metric. Trying to find the right dashboard. So give me a second. Get rid of that for a second. So AppDynamics has this concept of customer dashboards. You can create a custom dashboard doing anything that you want. It's a really nice nice feature. You can create something that looks very nice to put on a screen. You can make ones that are targeted at operations and developers, or you can take ones that are actually looking at more business metrics. Trying to find one. Oh, yeah. Okay, great. So this metric is like value of cart at purchase transaction and the total amount of money that I've transacted on the website over time. So this comes back to this idea of business value that we were talking about earlier. One of the things that you can do with AppDynamics and APM tools is that you have sorry, I need to find where I'm looking for, which is information points. Give me a second. Yeah, ticket sold. So in this particular, what they call an information point, I have the ability to extract information. So I know that I'm looking at this submit payment internal method. I know that there are parameters to that method. Because I'm inside the code with my instrumentation, I can go and actually have a look at what's happening in that code, and I can pull out the total amount that was paid, so which is this parameter number 3, and how many movies that I might have been buying for, and I can pull out there. What this means is that I can start to graph the actual amount of money that's flowing through my website at any one time, and I can start to correlate that with how the site is performing. So again, it's this concept of bringing business value into my my monitoring and using that to make informed decisions about what I'm going to do with my application and what I'm going to do with my infrastructure. So I'm conscious that we're out of time. There's many more features that I can show you. Hopefully that was a useful whiz-bang overview of AppDynamics. We've got 8 minutes left for any questions. B, do we have any questions from the attendees?
We have one question. It seems like there would be a lot of monitoring data. How is this typically managed, and when is it purged?
Okay, that's a good question. yes, you can generate large amounts of data. That's another reason why I like the SAS controller, as opposed to worrying about having to stand up a device myself. If you're going to do an on-premise installation, there is basically scaling guidelines and recommended hardware guidelines, based upon the number of metrics that you're collecting, the number of transactions or requests per second, the number of different transactions that there are. So there is like effectively a calculator that you can plug in that will tell you your storage requirements. In terms of the retention of data, there's a roll-up model. So basically, I can demonstrate that very quickly actually. You can quickly sort of see here, just straight away, if I'm looking at information over the last 4 hours, I've got a resolution of a minute. After 6 hours, I'm going to start to roll it up. 10 minutes after a day, I start to roll it up into an hour. So there is, effectively, like most of these things, you do an aggregation and a roll up over time. In terms of the actual snapshots themselves, snapshots last, I'm on the spot now, I think a snapshot lasts 14 days, and then all the detail of the snapshot is taken away. You can choose to archive a snapshot. So if there's a particular snapshot that represents a problem that you want to investigate, I can mark that to be archived, and it won't be auto purged. But certainly you can also configure those parameters. Certainly on an on-premise controller, at least, you can configure how long that you might want to retain that data for. Hopefully that answers your question.
I've got actually one more question.
Yep.
If a customer doesn't have an APM solution at all, what is the first step to take?
The first step to take, I think, is to, obviously call us, and we'll do you a what's called a proof of value demonstration. We'll take a small part of your, in some cases, your production environment, some cases a pre-production environment, and we'll just we'll install the tool and demo it for you. I think is the first thing. I think the real benefit of the modern APM tools is that they're very easy to get started. It's very easy to install the agent, start collecting information, and experiment. I think the old school method is I have to sit down for hours and create a massive project plan to work out what metrics I want to create, I want to gather, and where am I going to install it, and what's the impact, blah, 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 blah. DevOps is all about, rapid experimentation. It's about fact finding. It's about making decisions based on evidence. So my answer is just install it. Give it a try. Most of these tools, AppDynamics will give you a 14-day free trial of the enterprise product. They also have their light tier for both on-premise and SaaS, where you're restricted to the number of agents that you can collect data from, and you only have, say, 24 hours of data before it's purged, as opposed to obviously the, going back a year or something and rolled up metrics that you would have in a normal SaaS configuration. So yeah, give it a try. Put it into a non-production environment if you're worried. If you're a little bit bolder, put it into a production environment and get some real information. It doesn't have to cost you too much. The licenses are free. You might get some professional services charges, maybe if you want to get a consultancy report off the back of it. Yeah, give it a try. Dive in.
Thanks, Stephen. That's all the questions we have today. So I'd just like to end it by saying thank you to you for this insightful presentation, and thank you all for tuning in. Hope that was helpful to you. Bye for now.